Hey, sixth grade. So for our screencast today, we're talking about the structure of ratio tables. So go ahead and record our objectives. There's actually two within here. So the first is I can identify the additive / multiplicative structure of a ratio table. And then I can use the structure to make additional entries in the table and solve problems. So that means we're going to be looking at ratio tables and looking for the patterns down and across within the table. And so we'll see some patterns that have to do with addition and some patterns that have to do with multiplication. But then the second part of the objective is saying that we'll use those patterns that we see in the structure within the table to create extra entries, fill in more spots in the table, and to solve problems. So we're going to go through this first set together, and we're going to imagine that we're making fruit salad. For every quart of blueberries that we add, we want to put in 3 quarts of strawberries. Create 3 ratio tables, 1, 2, and 3, that show the amounts of blueberries and strawberries that we would use if we are making greater amounts. So table 1 should contain amounts where you have added fewer than 10 quarts of blueberries. So I'm going to start off with the 1 quart of blueberries that they give me here. For every quart of blueberries you add, you would like to put in 3 quarts of strawberries. So when I have 1 quart of blueberries, there are 3 quarts of strawberries. This entire table has to have fewer than 10. So I need to go 10 as my highest value. I can't go past that. For the next ratio table, it says table 2 should contain amounts of blueberries between and including 10 and 50 quarts. So the highest I can go here is 50. And the lowest I can go is that 10. And so I can really go like 11 to 50. And then table 3 should contain amounts of blueberries greater than or equal to 100 quarts. So the smallest value should be 100, and then I can go bigger from there. So let's go ahead and zoom in on our first table and determine how we're gonna get some of these values plugged in. I know that for every 1 quart of blueberries, I'll have 3 quarts of strawberries. So I'm already seeing somewhat of a relationship here. I know that 1 times 3 gives me 3. So we'll look and see if that pattern still continues throughout the rest of the table. I do see that from here, I'm going 1 to 10. I know that I can multiply times 10 to get 10. 1 times 10 equals 10. So if I multiply by 10 on that side of my table, I'm also going to do it on this side to see when I have 10 quarts of blueberries, how many quarts of strawberries will I have? And so 3 times 10 is 30. I'll have 30 quarts of strawberries. And now my values in between that 1 and 10 should also follow the same pattern where I'm multiplying by the same number on each side, starting with my 1. So I'll pick a couple more values, maybe 7 quarts of blueberries, 5 quarts, and 3 quarts. So it's almost going by odd numbers the whole time. And so now I'm thinking, how do I get from 1 to 7? Well, I multiply by 7. So 1 times 7 is 7. So 3 times 7 is 21. How do I get from 1 to 5? I multiply by 5. So 3 times 5 here gives me 15. And then finally, from 1 to 3, I multiply by 3. So 3 times 3 is 9. So my pattern this way is increasing, and my pattern this way is also increasing. And 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. 7 times 3 is 21, and 10 times 3 is 30. So I see a multiplicative pattern here. Where when I go across my table, we're multiplying by 3. All right, so let's check out our next table. Table 2, our highest value for the quart of blueberries would be 50. So if I started with that 1 quart of blueberries from before, I get 3 quarts of strawberries. 1 times 50 gives me 50. So 3 times 50 gives me 150. I'm going to pick some more values for this table. So I could pick 40, 30, 25, and 15. And I'm going to use the same rule that we did as before. So 1 times 15, 3 times 15. So 3 times 15 is 45. 1 times 25, 3 times 25. 1 times 30 is 30, 3 times 30 is 90. 1 times 40 equals 40, so 3 times 40 is equal to 120. Okay, so that pattern of times 3 still exists here. 15 times 3 equals 45. 25 times 3 equals 75. So we still see that multiplicative pattern of multiplying by 3. And then finally, we have our third table where we have to have values of 100 or greater. So just to show an example of an additive pattern, I could add 100 every time I go down in the table. 300, 400, and that's creating an additive pattern. This problem happens to show an example of multiplication, but you may come across a pattern of addition in your table as well. So I'll make my very last one 500 to finish off that pattern. And so now I know if I'm starting with 1 and 3, that I'll be multiplying by that value, just like we've been practicing. So 1 times 100 equals 100. 3 times 100 equals 300. Times 200 times 200 times 300 times 300. And so when I have this pattern of addition happening on this side, I also have a pattern where I'm starting to see skip counting by 9 on this side, or I'm adding 300 every time so far on this side. 1 times 400 gives me 400. 3 times 400 gives me 1,200. And times 500 is 1,500. So this time on this side, I'll show in blue, every time I go down another row, we've been adding 300 to create a pattern. And on this side, as you saw before, every time I went down a row, we added 100. And when we go across, we're still multiplying by 3 times 3 times 3. 100 times 3 is 300. 200 times 3 is 600. So we see patterns of addition and multiplication throughout the entire table. So now we have met part of our objective, right? We have identified the structure of the ratio table. So we saw multiplication patterns and addition patterns. That's the structure. It's how the table is put together. And we're going to use these values that we came up with to help us solve problems. So we came up with our additional entries, and now we have some questions to consider when it comes to these problems. So the first question says, describe any patterns that you see in the tables. Be specific in your descriptions. So we had 3 tables. One, 2, and 3. Now, we know from each table here, from our notes that we annotated, that each one had a pattern across of times 3. I'll say times 3 across. But But there was another pattern that we saw in each table, and so that was in table 3, we added 300 and 100 down each column. So we multiplied going across, and we added 100 and added 300 going down. And we can look for patterns in 1 and 2. 3 plus 6 plus 6. Because of the pattern I used here, we were adding 6 every time in table 1. And so then finally for table 2, I'm adding, I have to look for consistent patterns. So here I added 10, then I added 5, so I can't use that. I have to use the consistent ones, 30, 40, 50, that's each by 10. So when I skip count by 10, 90, 120, 150, we are adding 30. So when we skip count by 10, we are adding 30 going down. But a lot of this thinking from A we did together on the previous page when we were marking the text. So how are the amounts of blueberries and strawberries related to each other? As you add more blueberries, the number of strawberries increases. The amount of strawberries triples the amount of blueberries, or we saw that there are 3 times the amount. And we also see that as we multiply by 3 across the table. How are the values in the blueberries column related to each other? Well, we saw that we were adding each time. So the blueberries are related through additive patterns. So we saw we were adding going down. And the strawberries are also related through additive patterns. So I can show you that again really fast here. If we look at any of the 3 tables, we see blueberries and strawberries. When we went down the column from number to number, we added on the same amount. So I can clarify that here in orange. Add the same amount going down, and that's for C, and it's also for D. Okay, and then finally, if we know we want to add 7 quarts of blueberries to the fruit salad in table 1, how can we use the table to determine how many strawberries to add? Okay, well, we did this in table 1, but I can kind of record that thinking. So if we have blueberries over here, and we have strawberries over here on this side, when I have 1 blueberry and I need to make it 7, I multiply by 7. So when I have 1 blueberry, there are 3 strawberries. When I multiply that by 7, I get a value of 21. So the thinking that we did there was we used the table to triple to determine the number of berries through multiplying by 7. So we started with the original problem, what they gave us, and we multiplied by 7. And then our final question is, if we know that we used 70 quarts of blueberries to make our salad, how can we use that ratio table to find out how many quarts of strawberries were used? So again, we could have blueberries and strawberries. I know when there's 1 quart of blueberries, there are 3 quarts of strawberries. So I could use this multiplication pattern and figure out when there are 70 quarts of blueberries, there are 210 quarts of strawberries. So we could note that we use the multiplication patterns. Of times 70, what we really did was create equivalent ratios. So in the next exercise that you'll do with your team, there are ratio tables that were made incorrectly. So we're doing an error analysis, which means you're going to look at the table and determine what mistakes were made, correct them, and then make the ratio table the right way. And that's the same here. You have to fix the errors, make the ratio table the right way, and then when you feel confident, you can attempt our exit ticket. Thanks so much.